Hello reviewers, welcome to my channel Science Technology. In today's show, Rocket Monday, we're going to talk about SpaceX Crew-1. So let's dive right into it. Well, first, before you understand SpaceX, you have to understand its granddaddy, aka NASA. Now, NASA was formed in July 29, 1958. So this is an old boy, 62-year-old. Now, you have to understand it. Budgeting of something is directly proportional to the atmosphere. When this was created, it was an atmosphere of fear directly responding to USSR. To give you a context of that, at this point in time, both superpowers were developing ICBMs, rudimentary one, and randomly USSR is like, okay, we have ICBM and we're gonna remove the top part and we're gonna put a satellite and we're gonna successfully orbit this. There was no countermeasure that USA had. USA was like, whoa, I'm stuck in dark age. So they created NASA on a hurry. It's like, dude, get NASA done. Now, why NASA? First thing you have to understand, they had to show peaceful application of space technology. They cannot be like, they were already building ICBM. So it's like, you have to do peaceful system. And then president came along and it's like, no, we have to put a man on the moon before this decade is out. So that means they had to land on moon before 1970. And they pulled it off in 1969. Now, be mindful. That's why I'm specifying that fear response was the important aspect, because if you see NASA's budget, it never reached the height that it was achieving at this point in time. For example, to understand the context of this, take the national GDP and what percentage of it was NASA getting. At this point in time, they were touching 5%. At currently, they will be lucky if they get 0.9%. So that was the context. So you have to know that many times people are like, oh, why don't they go back to moon? It's like, dude, pay for it, they will go. It's like nobody can pay for it. It was like a fear kind of scenario. So they were like, letting the money run free really. But once this was done, they're like, okay, we defeated USSR. Like at least USSR were no longer a threat and they were dissolving at that point in time. So they're like, okay, done, that is a game over. So let's control our spending. We went a bit emotional. Let's control our spending. So solution was created is that Saturn V was amazing rocket, undeniably so. Till this point, there is no competition or equal to it at this point in time. But it was too damn expensive. So NASA is like, okay, a lot of engineering group came together. It's like, okay, we have some ideas, we have some suggestions. So some filtering was done, and then Space Shuttle was born. Now, Space Shuttle was created with core aspects. The core aspect was it should be cheaper. That was the main thing. It has to be cheaper than basically Saturn V. Otherwise, there is no point of doing it. And it has to be faster. What does that mean? That means Saturn V took a large amount of time. It's like, okay, we have to build Saturn V. It's like, okay, start the building process, start the assembly process. Assembly process alone took months. So fundamentally, they wanted to do something that is like, okay, it's cheap and it's fast. So basically, they wanted to build bus to space. So the idea was done in such a way that it's like, okay, just focus on low Earth orbit and get it as cost effective as possible. And their selling point was like this: this cost was like a joke how low they were aiming for that. But the main point was they will able to launch 2 missions per month easily. Be mindful, 2 launches per month easily. That was their target goal. Now they failed in everything. Fundamentally, every single aspect of it failed. For example, the cost, it overrun to such a point that like, dude, you could have done same thing with basically Saturn V, which much lower cost, simply because Saturn V has much larger capability, as in 150 ton to low Earth orbit, not 30 ton. So whole ISS could have been built in 2 or 3 launches. So fundamentally, it would have been cheaper, and per launch cost was also cheaper. And another aspect of it, if it was faster, it's like, okay, it's expensive equipment, but we can do fast. No, they went from like, basically doing 2 launches, supposed launches per month, to 2 launches a year. So they failed on that front also. Now all that a country can afford, as like, this was a union kind of system. They are like, okay, European Union is funding a lot of things, Canada is funding a lot of things, so many countries are pooling their resources, Japan is pooling their resources together, so they had to do it, so they could have afforded it. However, the main problem was it became the deadliest spacecraft. What does that mean? That simply means loss of life was severe. It was not like, oh, 1 accident happened, like 2 accidents happened. And because a space shuttle was such a big craft and it carried upwards of 7 astronauts, fundamentally they lost a lot of life. For example, Saturn V had no loss of life, nothing. Like they went to moon, they came back, even with incident, as in that happened in Apollo 13, they had no loss of life. But incident happened in Space Shuttle and 100% loss of life. There was nothing that could have been done, like flat out nothing could have been done. So that was the shocking moment. So once Columbia 2003 happened, it's like NASA was like, dude, we have to shut it down, we cannot afford any other risk. But they were like, okay, just complete the ISS. Once it's done, scrap it, like done, the end, game over, we cannot continue this no matter how much money they poured into, because they doubled and tripled their expenditure by the time Columbia accident happened. It's like after that they wanted to fix everything. So still, basically Challenger was the first wake up call, in Columbia was the second. Nobody wanted to have their third wake up call. So fundamentally this mission was scrapped. Consequence of that, not only because it was so expensive, there was no money left for a replacement. There was no replacement. It's like this was scrapped. So NASA went from basically having the ability to go to the moon to nothing. They had no space capability. So NASA in desperation created a movement known as commercial missions. So what does commercial missions? It has two categories. One is commercial resupply mission, which was like, okay, take payload, basically cargo, food and all the consumables into ISS. Your target capacity is around 9 tons. You had to send it to there, and they were very flexible in this time, rather than like, okay, this exact bolt you have to use, no, they're like, do whatever you have to do, get the specification, like meet the specification, only then we will take you seriously, and we're gonna test the hell out of it. We're not gonna like interfere, like do whatever you want to do, get the specification done, and then we're gonna do the testing. And you have to have enough confidence, is like, do the testing. So SpaceX saw this, a new company, a startup from Elon Musk, was like, okay, this contract is there. He wanted to bid into that. So to bid into that, he had to build a rocket. You cannot just like, hey, I want the money. No, you had to show that you had the actual capability. So Falcon 1 was built for this reason. Now, this is a privately held company. That means there is stock, there is value, but it's not sold in open market, so to say. So there is a lot of what we call private firms, investors and all that jazz, but not like, okay, oh, stock market, so stock value went up, stock value went up. You cannot do this with SpaceX, so to say. So NASA was this time, because the loss of money was so severe, they're like, okay, we only gonna fund you 50%, and we gonna call dibs on any launch. So if NASA is like, if there is a conflict of interest, it's like, okay, NASA has to launch in June and there is another satellite customer that wants to launch in June, NASA must get the priority. That was the requirement with that 50%. Where the else you will get the 50% from? That's supposed to come from private ventures. So in the first half, Elon Musk funded it from his own pocket. Then NASA started to fund it. Then the mission, it got more confident, and then more private venture poured into the money. Then he completed the mission. Then more satellite launches, and they were starting to make actual money. Now, be mindful, at this point in time, the money is like very low. It's like, they're pouring billions of dollars and barely getting few millions in profit, not in operational. Like, because of course they are making $1.1 billion, but here's the 1 billion was the running cost. So they were not making too much profit. So they started to make what we call Starlink. So this is the 3-part partnership with SpaceX. NASA is 50%, Elon Musk is 100%, and then private ventures, which includes Google. Google has already bought a very significant share into this. Now this was built, and this time NASA was not taking any chances. Basically, government was not taking any chances. So in 2017 or 19, there was a committee done. It's like, okay, SpaceX is consuming money, figure it out, is it worth money spending or not? So NASA did a thorough analysis, like, okay, you built Falcon 9, you built a system, how much it would have cost us to develop the system, not to make it launch it, like how much it will cost us. Their mathematics was 10 times more. Fundamentally, they could not have even imagined doing it on such a low price. So SpaceX became the savior at this point in time. Government was like, okay, you go ahead, because again, they've proven their point, and because they have private ventures, and because of the fact that they have the most advanced system at this point in time, there is no competition. It's like, okay, go ahead, and it's American. So Crew-1 was created. Now be mindful, at this point in time, SpaceX has thoroughly tested Falcon 9 Block 5. They have actually sent astronauts with the previous mission. So everything at this point in time is tested. Now the main reason why Crew-1 is important is the one designation. It's not a demo mission. It's like, this is it. USA is back. USA is like, okay, we got this. At this point in time, NASA has a space vehicle that is capable of carrying humans to ISS. The end. They no longer have to go to China. They no longer have to go to Russia. They never went to China, but you get the point. They have the only superpower that actually has space capability. So fundamentally, NASA is back. So they went from having the ability to go to the moon to nothing to back again, at least the low Earth orbit one. So this time, 4 astronauts were sent. The sole reason demo had 2 was like, creating redundancy. Same way aeroplanes have redundancy, they always have 2 pilots, same thing. So 4-1. Now the system is designed for like almost a space shuttle replacement, so it can carry 7 astronauts, but they are like, yeah, we don't actually need that much, so it's like keep 4 and the remaining space will be consumed by the cargo. And the actual testing which they done in demo 2, they realized the heat shield was eroding bit much. Now be mindful, at this point in time there was enough heat shield, so even if they had done no changes, it would have successfully came down. The repair time would have been much longer. So they are like, dude, let's reinforce it, let's be extra careful. people have learned their lesson from Space Shuttle. And solar panels needed a serious modification, because the solar panel in the last mission, they were like performing, but it was like, it's not gonna last. If they had kept the solar panels there for like extended period of time, for example in this mission 6 months, yeah, that solar panel is like nope. So fundamentally they had to redo the solar panel. So that's the whole point of this. However, they wanted to do this, and because it's a new system and 4 people are in a system, they wanted to like, okay, let's get there as quickly as possible. So they waited for a opportunity window where they're gonna launch it, they're gonna be in the launch window, and they're gonna dock to ISS very quickly. It's like launch, dock. But weather was like not kind at that point in time, so even though launch window was there, it's like that window to dock with ISS quickly faded away. Bad weather, they got delayed, so they launched it in a delayed scenario, and they had to wait 24 hours inside this puppy. The astronauts, like, this mission was so long, the astronaut actually had to sleep. Like, that was like a mission directive. Okay, all of you are not tired, go to sleep, then you will wake up the next day, then you're gonna do the docking. So you can literally see that 10-hour long basically SpaceX broadcast. They're like, okay, crew is going to sleep down, they remove all their clothing, basically spacesuit, and they're like comfortable, actually went to sleep, and then they wake up, like all the lines were cut, music was cut, like to allow them some time to sleep. So it was a very stress test, and in this time one thing kind of acted up, that propellant heater, they do have hypergolic propellant inside it for other stuff, and it was like the temperature started to go down. Now be mindful, the temperature never went down to red. It was like, it's a bit why they did not understand why the heck the basically amp heater, the resistive heater, was not working as they were expecting. Turns out it was a software glitch, but there was more than enough redundancy. They never went to redundancy department. But even if all the systems would have failed, and even though this mission was extended, they were expecting 4-hour docking, it went to 24-hour docking, everything was in green zone. Nothing was like, whoa, if this heater does not come back online, we did. Nothing like that happened. So it was a very good test, and like a very serious applause, so to say. It's like, no, we built a system, we have failsafe within failsafe within failsafe, and all of them performed admirably. So Crew-1 is the USA is back. So at this point in time, USA is like better late than never. So fundamentally, you have to understand this. Russia does not have a space mission capable of actually doing these things. The sole reason they have like a space program is simply because they are carrying forward the momentum which USSR gave them. So fundamentally, that's why you do not see their rockets getting updated, new systems being built. Fundamentally, they could not do that. They do not have the money. Their funding is basically lower than what you have China's wise. China is like spending around $11 billion something, which is second highest. The first highest is USA, aka around 22 billion. So USA gains back spacefaring ability. Now be mindful, they have learned their lesson from Space Shuttle, so they are like, dude, no matter what happens, USA should not have only one vehicle, no matter what happens, no matter the cost. So they are continuing progress in basically Boeing department. Be mindful, this puppy is much more expensive, much more delayed than SpaceX, but they're still gonna continue this, they're still gonna develop this. That for one core reason, they must have total system redundancy. Under no circumstances NASA should be in a position where they're like, oh, this project failed, so we are stuck. They do not want that, and this should be done by 2021. And there is a third system that is in almost completely done. Actual space testing has been done, which is Orion capsule. The capsule is ready, that system is done. All they have to do is get the SLS rocket working. So fundamentally, in few years, NASA will have 3 independent systems where they're like, dude, we have spacefaring capability, and we are like top of the world. Not like we can just pay for a seat in Russia. No, actual space capability, homegrown, 3 systems. So multiple redundancy, multiple fail safes, multiple failover, complete failovers. So they went from zero to hero again. So that is why this mission was so important. It's not like big mission, it's not boom mission. It's like, no, we lost the ability and we came back, and this time cheaper, efficient, faster, with multiple systems. So this was a very big movement for NASA, so to say. It's like, okay, they played a gamble on commercial system and it paid off. That is why that Crew-1 number is such an important thing. It's like, 1, we are back. So this was my presentation on Crew-1. I hope you liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment, and please leave a comment because I try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.